So here's problem 15 from the AP Calc AB Bluebook test preview. This is a calculator question that says that f is the function that has this derivative. How many points of inflection does the graph of f have on the interval 0 to 9? Excuse me. This is a calculator question, and honestly, the strategy that we're about to discuss here is probably one of the most useful strategies you can use across your calculator multiple choice questions. I'm going to fire up the Desmos tab here. And what I'm going to do is I'm going to graph this derivative. Now, I can't type it in as f prime of x because Desmos is going to think I'm asking it to do a derivative. I don't want Desmos to do a derivative here. I just want it to show me this graph. So I'm just going to type it in as a y equals equation. So y equals 2 plus. And obviously, when you do something like this, your calculator entry is going to make or break your ability to answer that question successfully. So just take the time to ensure that that gets entered accurately. And what I'm going to do with this is I'm actually going to adjust the range of values that I'm looking at. I only need to be concerned about this graph on the interval from 0 to 9. So if you open this little wrench, you want to change your x values to only show you the range of x values that you are currently concerned with, specifically 0 to 9. So check out this graph. Now keep in mind this is a graph of f prime. So f prime works its way up, then down, then up, then down, then up a little bit at the end. The question here is, how many points of inflection does f have? Now we would need to know how many times the second derivative changes signs in order to answer that question. Now because this is a graph of f prime, the slope of this graph is what determines values of f double prime. F double prime is positive on this stretch due to positive slope, but then it changes to negative at this maximum on the graph of f prime. So we do have a point of inflection here. We actually have another point of inflection here because here's a spot where f prime is going to change signs from negative back to positive. So we've got 1, 2, we've got a third here where we have a change from positive slope to negative slope, and then we have a fourth inflection point on f down here where the slope of f prime changes from negative back to positive. So for this particular function, based on using the graph of the derivative and identifying the slope of the graph as what represents values of f double prime, we see 4 sign changes for the slope of f prime, 4 changes for the sign of f double prime. That's our conclusion for this problem.